Alright, so welcome guys to EGME 306A. My name is Patrick Phelan, so I'm going to be your instructor for the semester. So some background on me, I'm a grad student here at Cal State Fullerton for mechanical engineering. I did my undergrad here as well. So I'm in my last semester for grad school, so if I know some of you, just by looking at this class already, I recognize some of your names from last semester or even a few semesters before, but this will be the last time that you see me, probably. So you might see me around campus, just, even besides this class. I'll probably be around campus sometimes. So you don't need to call me professor or anything, because I'm not a professor, technically. I'm just an instructor. So you could just call me Patrick, though. I'm totally fine with that. Alright? So, yeah, sorry, I'm going to be leaving you. With that said, today's going to be pretty relaxed. Not going to be too intense, just like one of you were saying earlier, the first week, mostly syllabus stuff, right? So it's not going to be too bad. So let's go first. I want to give an overview of our course site. So I'm sure like all of you already saw how to use Canvas from your other classes, but just in case, once you sign into the school website, you're going to be on the homepage here. Click on Canvas, then you go to your dashboard. And for us, we're 306A-10. Why do I have a picture of Patrick? I don't really know. My name is Patrick, yeah, but I don't know. I want something fun and not boring, right? So that's us. This is the homepage for Canvas, so I decided to kind of organize it this semester where it's going to be by lab. So we have 6 labs for this course, and all of these pictures, once we get to that lab, it's going to be clickable. So for the first week, you can click on this, or the first 3 weeks really. You can click on that, and this leads to a module that's going to be for this lab. So we're going to have week 1, then week 2, and week 3. Okay, so that's the general gist, but everything on here on the homepage, we have the link for Zoom. That's going to be for all of our lectures. It's going to be the same link. We have the link for office hours here. For the syllabus, and if I ever update it, it's basically just going to overwrite what I already have on Canvas. But you can access that. I don't have any plans to update the syllabus, but if I ever do, I'm going to tell you. My contact info, you can check that out. It's got my email there. Discord, I'll talk about that a bit later, but I already saw that, like half the class is on there. And then my YouTube channel, that's where I'm going to upload recordings of the lectures that we have in class. And then over here is VKS, so we'll talk about that a bit later. That's an online, it's a website that Dr. James made a few years ago to kind of have like pictures laid out for the labs, for the procedures for the labs. But we'll talk about that a bit later on, and I will give you the username and the password that you need for that too. Okay, so for week 1, let's click on that. And also, if you guys have any questions throughout this lecture today, you can feel free to use your mic or use just in the chat, whenever you want. Okay, so on here we have the intro slides. I don't use slides very often for this class. Usually I write on my iPad once we actually get to the lectures, but I made some slides for today. And I'm always going to have a schedule that's kind of laid out for the lecture. It's going to be pretty basic, but I'll always have that. And then if you have any assignments, which is just going to be a lab memo, I will also post that, and it'll also be, of course, on the assignments tab. So let me go to the student view. So when we have assignments, I guess I don't have that up here right now, but that will come up. You'll see assignments over here on the left, and you can click on that, and you'll see it's just going to be the lab memos that we have. Also, you can access basically everything that I upload for this course just by clicking on files over here on the left. And then I'm going to have everything organized probably by lab again. So it'll be a folder for lab 1, another folder for lab 2, and so on. Right, and then the syllabus will always be right there. All right, so any questions, any general questions or anything before we get started on going over the syllabus? Okay. All right, so let's go over actually, we're going to go over the syllabus a bit later. I'm going to open up my slides, and we're going to go over the course first. Of course, I opened up the syllabus. Didn't want to do that. On autopilot. Yep, so there's a question, when are we going to talk about, or are we going to talk about when we have class on campus? So yeah, we're going to talk about that on the very first slide. So this is a hybrid course. Let me make this bigger, like that. Okay, so this is a hybrid course that we have for this lab. So for us, what that is going to mean is that we are going to have all of our lectures online on Zoom. And again, it's going to be the same Zoom link all the time. And the only time that we're actually going to be on campus in person for this class is for the experiments that we have. So even for the final, once we get to that, I'm at least planning right now on having that online. All right, so also I'm going to always try to make it clear on Canvas whether we're going to be in person or online. So again, if you click on the the module for that lab, and you can see it's organized by weeks as well. You can click on that, and for the page for each week, I'm going to have in the title whether it's online or in person. So the first 2 weeks are going to be online, and in the third week, we're going to have our very first lab that'll be in person. And of course, if you guys ever don't know if it's online or in person, you can send me an email, or even better, just for everyone else in the class, you can ask in Discord, and then I'll answer there. Okay, and our meeting times always, they're going to be every Thursday at 8:30 a.m. to 11:15. It's hardly, I don't think we ever actually take the whole time, even for the experiments. There's one experiment where we might, actually maybe two, where it might take the whole time or just about, but I don't think that's ever happened. So usually we're not going to take too long. Okay, there's a question, will we have one lab on average for every 3 weeks? So yeah, that's actually not every 3 weeks. That's just in the very beginning. After this, it's going to be about every 2 weeks. So kind of what we do is have a lecture, then have a lab, have a lecture, have a lab, and keep going like that. So there are 6 labs for this course. Okay, so hopefully you don't need to be like Tina here, by the way. You know, if you guys get COVID and you have to do a lab, you're going to have to make it up. But, you know, we're on a Thursday, so your only chance to make it up is going to be on Friday. If you're sick, that's probably not going to happen, right? You don't want to go to school if you're sick, whether that's any illness or COVID, of course. But if you are sick, reach out to me, let me know, and we'll kind of work that out for how you're going to proceed with that lab. Okay, so any questions so far? Okay, and also in person, once we meet on campus, that's going to be in the engineering building. It's actually in the quad. All of you, well, most of you are probably underclassmen, I think, or maybe you're juniors, I don't know. But if you don't know where this classroom is, it's kind of in the quad in the engineering and computer science building. I'm sure you can look at it on the map. So we're going to meet there anyways. Once we're in person, we're going to meet first in the class, and then we're going to walk over to the lab as a class. Okay, so Canvas, we already kind of talked about this, but everything on the home page, it's organized by the labs that we have. Okay, I'll put you there. So we have 6 labs once again, and each of these pictures you can click on, and it'll take you to a module page where it's going to be broken down by week. So it'll be for the lecture and then for the lab. Yeah, right. Yeah, thanks, Marshall. Yeah, so our classroom, E22, it's right next to Baja and the formula room. So it's again, it's in the quad. So if you don't know where those rooms are too, just walk around in the quad and you'll see E22. Okay, so lecture recordings, they're going to be uploaded. Once again, I will have that link on Canvas for that week. Or you can just check out my YouTube channel where I upload all of my lectures and you can get them there. Lab data is also going to be uploaded on Canvas. So here I say do not use a flash drive once we actually get to the lab. I know, of course, that's logical. You would want to use a flash drive once you have, you collect your data. But the lab technician really doesn't like that. So basically what I will do is I will use my own flash drive. I'll go around to each of the workstations that we have in the lab. I'll get the data that you guys collected, and then I will upload that to Canvas, within the hour. So we got to do it like that. And your lab memos, which we'll talk about soon, they're going to be uploaded on Canvas, and I'm going to grade them on Canvas as well. Okay, so before we talk about the syllabus, I want to kind of give a bit of an overview for the experiments that we're going to do, just to give you an idea of, what the hell we're doing in this class. So, very first experiment is a pretty cool one to start out on. The title is boring, yeah. It's stress and strain and the extensometer. So the extensometer, that's this little tool or device, whatever, that you see here. Of course, we're going to talk about that in depth next week once we actually get to the lecture. But basically for this lab, we have 3 different rods of metal. So we have an aluminum rod, steel or 1018 steel, and 1045 steel. And for each of these rods, we're going to use this machine that you see here. It's called the MTS Insight Tensile Testing Machine. And we're going to apply tension to these rods, and we're going to keep applying tension until they break. So you're going to see it's going to basically split in half. And it's really loud, so I'm telling you that now. Just be prepared. It's going to be like, it almost sounds like a gunshot. It's extremely loud, so be prepared for that. And you'll see you can kind of tell when it's going to fracture, but it's not like down to the second, so it can be a little surprising. Alright, the second lab is really similar to the first lab. We're pretty much doing the same thing. You see that we have the same tool here, the extensometer, but we're going to add on another tool, which is this strain gauge right here. And this time around, we're not going to break this rod that we have here. And I think for this one, we only use aluminum. So we're only testing one material this time. And basically what we're doing is we're going to measure strain using both of these tools, and we're going to compare them and see which is more accurate to the theoretical model that we have. All right, and then for our third experiment, this is called the beam. So we have this beam with an eye cross section, and it's simply supported. So we have a support here and a support over here, and then we apply 2 loads in the center. So there are 2 equal loads. And what's going to happen, this beam, it's going to deflect downward. So, it's going to bend. And once it bends, it's going to have a maximum deflection right there in the center. And we're going to calculate that with the equations, and we're going to measure that. With this tool right here, you can see there's like a little tip right there, and that measures the deflection. And we're also going to measure the maximum bending stress on this beam. And again, we have equations for that, and we also have experimental methods to calculate that. And for this one, we're not going to break it either. That would be pretty intense. It's a pretty good sized I-beam here, right, for a lab, so we're not going to break it. All right. Next one, experiment 4, this is the column. So this one is honestly usually a big pain in the ass to do, at least if you're measuring the deflection outwards. And sometimes we actually don't measure that. It kind of depends on the semester. Lately, in person, we haven't been measuring the deflection because, again, for these like really short rods here, it's extremely hard to measure it. Just because it can deflect in any direction, and it's hard to first find that kind of plane that it's deflecting. Anyways, I don't want to talk about it in too much depth, but for this experiment, we have a variety of hollow aluminum rods, and they vary in length from, I think, 1 inch to 12 inches. And with that, we have different fixtures that we have on our machine. So it'll be either pin-pin, pin-fix, or fix-fix. We'll talk about that once we get to it. And we hook them up to the fixtures, and then we apply a compressive force. And we'll see when each rod fails. So it's either going to fail by basically crushing, and that'll be our short rods, or it'll buckle out a lot. So the really long rods, they're going to deflect outwards quite a lot. And we are going to basically look at the differences for all of these different rods, what the maximum load is before it fails, and how it failed. Alright, lab 5. This one is pretty fun. It's probably one of the more cool ones in my opinion. It's the Charpy Impact lab. So here, this is our Charpy Impact kind of test station, which is really just a huge pendulum. It's like 60 pounds, I think, so you gotta kind of have some good form to lift this up and not hurt your back. So anyways, what we have here is 3 notched specimens of aluminum, 1018 steel, and 4140 steel. So they're like an inch long, and you'll take that and you'll put it down here. And you'll see that you can kind of slide it in nice right there. And what we do is we lift up this pendulum, and then we release it. It's gonna swing down, it's gonna hit that specimen that we have down there, and it's going to break it. And on this front panel here, you can read the amount of energy that that specimen absorbed. So the cool part for this lab is, apart from breaking things, which is always kind of fun, we're gonna have all of these specimens in a variety of temperatures. So it's going to go from liquid nitrogen all the way up to being in an oven. And basically what you want to do is you want to take it from that environment and as fast as you can put it on the test station and then, break it. And basically what we're going to see is how these differences in temperature affect how much energy that specimen can absorb. So some materials, they aren't affected by temperature too much, and others, are drastically affected. And afterwards, once we break it, we're gonna get this, I wouldn't really call it a microscope, it's almost like a really good macro camera, and we're gonna take pictures of the fracture surface, and you'll see some materials, if they absorb a lot of energy, it's gonna be this very rough fracture surface, and if they don't absorb a lot of energy, it's gonna be this very clean cut surface. So it looks kind of cool, to be honest. Alright, and then the very last experiment, this will be probably 2 weeks or something before our final for this class. It's going to be the double shear experiment. So you also notice that for a lot of these experiments, we're using the same machine. We have different kind of fixtures that we attach to it. You don't have to attach those, the lab technician does. A lot of it is set up pretty well for us, but of course we have to do some setup ourselves. Anyways, for this experiment, we have 3 different materials: aluminum, 6061, copper, C101, and 1018 steel. And for this, you see that we have a little rod here. And we're going to apply force down. And what's going to happen is we're going to break this via shear, basically, along two different planes. So we have one plane right here and one plane right here. So we're going to shear that rod in two different spots. And we are going to basically measure the maximum load that each rod can handle. And then we're going to look at the fracture surface, just like we did with the Sharpie impact test. We're going to do that for this as well. So you'll see, like copper, it smears is the word that we use. It smears quite a lot because it's a ductile material. So it's kind of a cool lab. It's not my favorite, to be honest, but it's, I don't know, it's a easy one that's still kind of interesting at the end of the semester. Alright, so I know I went over all these kind of fast, but I just want to give you a little preview as to what we're going to be doing throughout the semester, so you have an idea of what we're actually going to be doing, and it's a stress mechanics lab. So any questions on the labs at all? Oh yeah, good question. So will we be breaking off into groups of 4 to 5 for these? Yes, exactly. 4 to 5. So we're gonna have 4 groups. Each group will have 4 to 5 people in that group. So you've kind of been seeing from all of these images the kind of different spots that we have stations in the lab. And I just found out a few days ago that one of these stations is actually moved back here where this cart is. And that's to help, space us out a bit more. So, you're going to be in a group of 4 to 5 people like we said. So you're going to be kind of close. You need a mask indoors on campus. But, at least we moved the station over here in the back. Well, one of them. So we're a bit more spread out. And as for how we're actually going to break you guys up into groups, I'm thinking we're going to do that basically before the lab when we meet in person. So, we're going to meet in class at E22. And before we head over to the lab, we're going to break off into groups. So you'll choose your groups then. Okay. Any other questions on the lab? Okay. So now let's see. I know this says we're going to go over VKS in the syllabus. I want to make sure that the schedule doesn't say anything different. Okay, question. Do we know what weeks will be in person? Yeah, so in person, we're always going to be in person for experiments, and that's the only time. So whenever we have an experiment, we're going to be in person. I have the dates for the experiments listed on the syllabus, and I'll also, post them online. So that'll be on this module page. So actually, I'll add this after class. So I'll add week 2, that's going to be online. We're going to have our lecture next week. And week 3, that's our first experiment, so we're going to be in person. Yeah, I don't want to have any repeats for you, where you go to school for, when no one's there. Let me go back here. Okay, overview of course and experiments. Okay, so VKS, let's go over this now. So I just added this before class started. I forgot to give you guys the login for this. I did not make the username and password, by the way. I know it's not the best. Okay, so let's go back to the home page. Up top here, we have a link for VKS. Again, Dr. James made this with a grad student a few years back. So let's sign in. I think I typed that wrong. Yep. Okay, so once you sign in, this is going to be the home page, and you'll see that there's only 5 experiments here. The fifth experiment, the Charpy impact, there's nothing on that on the website. But that's a pretty simple experiment, don't worry about that. So for 5 of these experiments, we can click on this eye right here that says View. And that'll load up the procedures that we have to do for this lab. So in years past, the procedures for each lab, they've only been on a lab handout. And I mean, that's okay, but I think it's a lot better to actually see visually what you have to do. So before I kind of give you a little preview of this, I also just found out just yesterday that the computers in the lab and the software in the lab have been upgraded. So I'm not sure how useful VKS, this website, is going to be, because the software, from what I've seen, it's vastly different. So this will still help either way to give you an idea of what we're doing, but for the actual each minute step, I don't know how useful it's going to be this semester. But once I get a better idea of the differences for the software, I'll let you guys know if you can still use this, like following it really closely or not. So anyways, once you load up each lab, you can scroll through here and you can see what you have to do for the lab. I'll still give you guys the lab handout, which is a PDF, and it has each step numerically that you have to do. And of course, I'm in the lab with you as well if you have any questions. But this is really nice because it shows you all of the steps. So this is what the software has looked like every semester that I've taught this lab, but again, it's been upgraded to something, at least from what I've seen in a video that Dr. Sue sent out, it looks really, really different. So, anyways, you can see, again, the general steps that you have to take in the lab. Steps like this, where we're actually using the machine, this will still be very useful. Again, this is the extensometer that we have in the first lab. By the way, I don't think I mentioned it. If you're curious, what this does is it basically deforms at the same rate as the material that it is attached to. And that deformation, it gets sent to the computer, and from that we can use that to calculate the strain. So there's quite a lot of pictures here, so it's nice because it's really detailed. So that's what, I think this is probably one of the steel rods. That's how it looks when it fractures. The aluminum one is going to look a bit different. Alright, and this is just talking about where to save your files. I'll go over this actually in person once we're actually in the lab. Okay, so anyways, that's what it looks like. And again, we have that for every single lab besides the Charpy impact one. Alright, so that's VKS. I think it's a really good resource, even if the software is different. Again, you can look at the steps for, dealing with the machine. Okay, so now let's talk about the syllabus. So the syllabus that's on the course homepage, if you haven't downloaded that yet. So you can do that by, again, going on our homepage and just click on syllabus right there. Of course, right when I try to click on it, it changed. Okay, syllabus. And that'll open up that file. Okay. So I'm just opening it up on my computer here. So for the syllabus, I have all of the links that you need for the class on here as well. So we have the link for our lectures for Zoom, and we have the link for my office hours. So first off, just to really repeat myself here, all of our lectures are going to be on Zoom. And so that'll just be the same Zoom link every time. The only time that we're going to be in person is when we have a lab. And we're going to first meet at E22 And then I'll kind of talk about what we're going to do for the lab, kind of brief you a little bit. Then we're going to head over to the lab, and if there's anything to talk about in person, to kind of like show you things for the setup in the lab, I'll do that. And then all of you will work on the lab. Okay, we're meeting every Thursday at 8:30 a.m. to 11:15. Probably never going to take the full time. Okay, office hours, again, they're on Zoom every week on Monday from 11 to 12 p.m. If you can't make that time, which I'm sure some of you can't, that's fine. You can schedule an appointment with me throughout the week. Just contact me either by email or in Discord, send me a PM on there, and we can set up a time. I'm also on Discord very often, so in the past few semesters, I've answered quite a lot of questions on there. If you have a question, first post it in the main chat though for that lab on Discord, because chances are someone else asked the same question, number one, and maybe one of your classmates, they know the answer to that question. So I'm always available to answer your questions directly, but I don't want to answer like the same question in a PM like 20 times, right? So if you have a question, kind of the first line of action is go in Discord, post it in the chat for that lab, and either a classmate will answer or I will answer there. Or again, we can have office hours or a different meeting. Okay, my email, pphalen@fullerton.edu. Course description, I'm going to skip. We already looked at all of the labs that we're going to do. Prereqs, Physics 225. I don't even know why that's a prereq. I guess just because you took it already, but there's no like Newtonian physics in this lab, or nothing that we are concerned about. Also, AutoCAD, I guess, is a prereq. We're never going to use that. Corec 205, so that's MATLAB. I think most of you have already taken MATLAB, and that is going to be required for this course. I'll talk about that in a bit. And then your stress mechanics lecture, that's a Corec too. Some of you, I think, have already taken it, and some of you are going to be taking it now. Text, you don't need to have anything. It says required here for my instructions that I give you guys. That's really going to be the lab handout that I get from the department. I'll give that to you on Canvas. Actual textbooks, you don't need any, so don't worry about that. Okay, before I continue, any questions on the syllabus or anything at all? Okay. So, course outcomes. We're going to be doing experiments as a team, and that's basically it. Okay. Attendance, it's mandatory. So, again, if you miss a lab, it says you have to make it up, and really, I want everyone to do every single lab. It's really important that you show up to do the lab if you're healthy. If you're sick, don't show up. That's not a good idea, whether it's COVID or any other sickness. Don't show up if you're sick. Let me know if you're sick, and we'll see if you can make it up with either another of my classes. Let's say like I somehow get out of sync for my Thursday class and my Friday classes. I don't know. Just let me know, and we'll see if you can make it up. If not, basically what I'll do is I'll give you the data, and you'll just go through the data reduction. But I really want everyone to do every single lab, if you can. That's the expectation. Okay, Discord, so I mentioned that briefly, but we have a Discord server. Let's see. Yeah, so there's like, I don't know, 15 of you or something that are in there right now. This is the invite link. The invite link is on the homepage on Canvas, so you can join by clicking on that. So in the past semesters that I've had it, it's been pretty active, so I expect it to be pretty active again for talking about the labs or, anything. I don't care. I just need to be respectful to others. That's never been an issue. Okay, the grading breakdown. only two things, right? It's only two sections here. So we have lab memos. That's going to be 80% of your grade. We have 6 memos that we're going to have. So that's going to be, obviously each memo is going to be very important to do well. And then our final exam, which we need to have, that's 20%. And the final exam, I'm planning on that being online. And for me, well, I'll first say that when I took this lab, a lot of my final exam was really theoretical. It was kind of like the EGME 331 final that I had. And I thought that was weird because this is a lab, not a lecture. So for my final, you may have 1 or 2 theoretical questions. They'll be pretty simple. But what I like to focus on is questions related to what you did in the lab. I want to make sure that you understood what you did with the equipment that we had and why we did certain things. So the questions are focused on the actual lab and the experiments, that kind of stuff. Not as much the theoretical questions that you have in your actual lecture. No, the final's not going to be hard. If you show up to each lab, you can breeze through it. I don't think anyone has done poorly on my finals for this, because again, it's really just to make sure that you paid attention and you were participating in the actual experiment. So yeah, definitely don't worry about the final unless you never show up to lab, which if you never show up to lab, you're going to fail the course. You got to show up to lab. And it would be hard to do bad on the final. I'll put it that way. Alright, and then, there could be a curve at the end of the course. I've never had to curve a class, though. So that's most likely not going to happen. People usually do pretty well. That's not me telling you to not try, because if you don't try, then you will do bad. But usually the overall course grade, especially for labs, is pretty good. Alright, late lab reports. So in the past, I think I've been a little too lenient on this. So I'm going to enforce this semester. So each day that you have a late lab report, 10% is going to be docked off, and this will occur up to 5 days late, and then anything after that, that's already almost a week late. At that point, you're going to be given a 0. So for me, if you turn in a lab really late, like a week late, it's, I have to go back and kind of, I've already graded like all of the lab reports, and to go back and grade, some stragglers is just very inconvenient and out of the way. So make sure you turn in the lab report on time. If you're a day late, you're going to get 10% marked off, again up to 5 days late. So you're going to have 2 weeks to do it. So you have a lot of time. By the way, I might say lab report or lab memo. I mean the same thing. So yeah, and we're going to talk about the memo structure basically right now. Okay, so the lab memo or lab report, whatever you want to call it, they're going to be submitted as a PDF on Canvas. And I will have the due dates posted on Canvas, but it's also posted on the syllabus. So, this is the tentative schedule that we have on the syllabus. It's at the very end. Things might change. If they change, I'm going to post the revised dates. Okay, the report has to be typed. Lab reports, they're done individually. So I do that. One, it's just better for you. You're going to learn more that way. But it's also more fair for grading. If you have a team member, hopefully this isn't the case, but if you have a team member that's not helping with the lab or something, and they hardly put in any work, you don't want to be, have your grade kind of reflected based on their work. You want to be graded on your own work. So I have them done individually. That said, you can definitely work with others to work on the data processing, which we're mostly going to do as a class, by the way. We'll talk about that in a bit. Actually, right now. Okay, and yeah, you can go into Discord, talk to me, talk to your classmates about how to do whatever you're struggling on, maybe for the data processing, or if you have just a question on the lab, feel free to work together. But your final, end product for your memo, that should be your own effort. Okay, so the use of MATLAB, it's required. I require it for this class. I don't want you to, shit your pants or anything, because I know if I was told when I took this lab that I had to use MATLAB, I would be kind of freaking out a bit. I did not know MATLAB well at all back then. But we're going to be doing a lot of the data processing together as a class. Yeah, so Samson, you say that you suck at MATLAB, that's fine. I wish that wasn't the case, but yeah, we're going to be doing a lot of it together as a class. MATLAB is an important skill. Really, I should say coding is important. So it's very useful too. So yeah, we're going to be doing a lot of it together as a class. I'm not totally sure on the structure of that yet, whether it's going to be all online. Most likely, just partly because of convenience and most importantly because of COVID. But don't freak out. For anyone that thinks they suck at MATLAB, don't freak out, really. We're going to be doing a lot of it together. And if you have questions, you can ask me as well. Okay, so the memo structure and the weighting that's given here, this will be for every single lab. This is going to be the format. So you're going to have an abstract. Most of you probably have written abstracts before. So for that, basically, and we'll talk about this as well once we get to the first lab, because I want to make sure you guys do well in this. So basically for this, though, you give an overview of the experiment, why it's important, what the objectives were. Procedure is very high level, meaning keep it really general. And then your main results. This is really important. What were the main results in the experiment? And you want to include the numbers, the relevant numbers. Okay, then we have a results section. That's going to start out with a general procedure. It's going to be a little more detailed than what you had in the abstract, but I don't need to have a very detailed procedure here. You can if you want, but I don't care about that. You can keep it pretty general. I know a lot of this so far is kind of vague, right, what I'm saying, but you'll get a much better idea once we approach the actual lab memo. Okay, then we're going to have quantitative results. So, what were the actual results that you had, and then the relevant plots that you need to have. And for all of the results and plots that you present, you need to interpret that data. So you need to discuss what that plot tells us, because what I don't want is you to have a plot and you don't even talk about it at all. You just copy and paste your plots and you move on. You're like, okay, I'm done. That's my results section. That's not good. You need to discuss it a bit in the results section. Okay, and then the discussion and conclusion. This is where you're going to expand upon the results that you just presented up here. So when I say that, you're going to basically restate your results with the numbers, the important ones, and you're going to discuss the importance of them, and you're going to have an error analysis here. So were your results expected? What was the error? What were the possible sources of error that you had? Were they, a fault of the machine, a fault of the user, maybe a certain tool was malfunctioning, whatever it might be. References, this will be if you have to, let's say, have a % error to a published value of the elastic modulus, something like that. You need to have your source for that published value in your memo. So basically this is really just 5 free points. So make sure you do this because you don't want to miss out on free points. The appendix section, this is when we're going to have our data sheets if we have any. Most important thing is the sample calculation. So if we are, let's say for the first experiment, That's a stress-strain experiment. So the sample calculations off the top of my head here are going to be for stress and strain. Really simple. You just need to have one calculation for each, and that's it. You're going to go through that entire calculation, and that'll be it. Again, for a lot of this, I'm going to show you examples. I would like to do that just so you're, very clear on what you have to do, what the expectations are. All right, last thing is formatting and clarity. So again, hopefully this is 5 free points, but it's typically not the case. But I give you everything I'm looking for here. So is your lab memo, is it generally consistent and clean with the structure? So I mean, is your formatting consistent? Like, are your headings, are they all the same? Are you using the same font size throughout, the same font? It might sound petty, but it's got to look consistent and professional. Okay, all of your figures and tables, they have to be captioned. And you can set up like captions that are kind of set up I guess semi-automatic in Word. So if you have a figure, it'll automatically like put figure whatever it is, and then you can type in the caption. Alright, and then all of the other things, they're just small things. You can kind of look through that. Alright, lab report format. I'm not super, I guess, what's the word I'm looking for? Strict. Okay, I'm not super strict on this format here. So I don't care if you don't have this exact header, where EGME 306A is in the top left of your page and the experiment name is on the right. I'm not super strict about that. Really, I just want your reports, again, to look consistent and professional. Alright, lab safety. You need safety glasses. That's the most important thing. So if you don't have any right now, make sure you get some. I think, at least in semesters past, they've sold safety glasses at the bookstore on campus. So if you go there, what's it called, like Titan Shops, right? If you go there, you can pick up a pair there. Make sure you wear closed-toe shoes. I can never say that well. Closed-toe shoes and long pants. If you aren't wearing closed-toe shoes, the lab technician is going to get mad. So you need to make sure that you wear them, or else you will get kicked out. So make sure you're wearing shoes. Okay. If there's any accidents, you gotta let me know, or the lab technician, and we're gonna have to report that to the department. I don't think that's ever been an issue. Alright, if you have special needs and you need some kind of assistance or accommodation, make sure you contact DSS. So there's their email or their phone number, and then they'll get in contact with me, and then I'll make sure that you have whatever accommodation that you need. Academic dishonesty, don't cheat, right? There was a bit of an issue with that for one of my classes last semester. Not for a lab, but make sure you don't cheat. It's going to be a pain in the ass for you. It's a pain in the ass for me. Just don't cheat. You can work together on the lab reports, but what you type out, it's got to be your own work. So if you copy and paste, your classmate's abstract, I'm gonna notice that really easily. Not even, like Turnitin or whatever services aside. It's really obvious when you guys copy and paste different sections. So don't do that. And I'm thinking about actually using Turnitin, by the way, this semester, just to make sure that there's no cheating going on. And it's always gonna say like that you have like 3% is the same or something. That's just by nature, like your results might be the same, right? Or some sentences might be the same. That's okay, but it's obvious when you are directly copying and pasting. Okay, so I missed a question. For the safety glasses, do they have to be, do they have glasses that are protective goggles? I'm not sure about that, actually. I want to say yes, but I'm not 100% positive. It's been a while since I've been in that shop. Yeah, you don't need protective goggles. If you prefer that, then of course you can pick those up, but I'm not sure if Titan Shops has goggles. I know they have glasses, at least the last time I was there, but goggles, I'm not sure. Okay. Very last thing on the syllabus is our tentative schedule. So, things might change, you know. Whether, let's say, I get COVID, right? Well, then I can't go and help you guys with the lab. So, if something like that happens, we're going to have to delay the lab. You know, there's usually one or two things in the semester where either lecture is delayed or lab is delayed. But that it's always okay. It works out in the end time-wise. But this is the tentative schedule as for now. So, week 1, you know, we have the intro to course. Next week, we're going to have our first lecture. Week 3 is going to be our first lab. And then we're going to keep going in that format. So lecture, lab, lecture, lab, lecture, lab. And you can see the tentative due dates for your memos. So you have 2 weeks to work on your memo for when it's due. That's the case for every single memo you see for like Sharpie Impact. That's a bit different because we are, for the Sharpie Impact, because we have actually, yeah, that's due there. But for Memo 6, that's a bit different because of the recess. So, usually, you're always going to have at least 2 weeks, though, to work on your memo. Alright, and the final exam, it should be on Thursday, but if there's any conflicts, let me know, and we'll figure out a day that works for everyone. But again, it's most likely going to be online, so it's going to be very flexible. Alright, so that's the syllabus. Any questions on that? Okay. So, alright, the last thing then is going to be MATLAB in dark mode, so, yeah, this will be real quick, okay? I'm doing this just because I know people love dark mode, right? I love dark mode. Go over here. Why did I move that? Okay, my video just went away. I'll pop that back up. Where did I keep that? Is it here? Yeah, okay. Alright, so if you don't have MATLAB installed right now, that's fine. Make sure you install it though. If you type in CSUF MATLAB, then you'll be taken to a page where they show you all the steps to install MATLAB. So for dark mode, by the way, so I'm going to do this real quick because, you know, we've already been going for about an hour now. But the instructions for this are also on the slides that I have posted for today. But if you want dark mode for MATLAB, this is what you're going to do. So MATLAB, they themselves don't have anything built in for dark mode. I don't know why. It's 2021 and they still don't have that. It's insane. But what you want to do for the best option that you have is you're in MATLAB here, you're on the Home tab, click on Add-ons here. So if you're not following along, again, don't worry, it's in the lecture slides, or you can just watch this video back later on. So we click on Add-ons, then we're going to search for MATLAB Schemer. Okay, and we're going to click on the very first one right here. And all of these add-ons, I think MathWorks, you know, the company from MATLAB, they vet them and they make sure that it's, you know, not like malware. Okay, and this has, you know, a lot of downloads. I've used this for years. It's safe, don't worry. So you'll see over here on the right, it's going to say, I don't know, like add to MATLAB, something like that. Again, you can check the slides. I've already downloaded it, so you see I have different options, open folder and manage. So if I click on open folder, you'll see over here on the left of MATLAB, my current folder is going to change. It's going to change to where MATLAB Schemer is installed on my computer. So I'm going to click on open folder, and you see that this changed over here. And we're only doing this so we can look at the different schemes that are installed by default for this. So how do you change your theme? You type in schemer _ import, and then whatever theme that you want. So that's again why I opened up that folder over here. So anything with .prf, that's a theme. So we can type in monokai, I don't know, .prf. So prf, that's the file for the theme, or the file extension. We press enter, and there we go. Now we've changed our theme. This is the best that you're going to get for dark mode. Up top here, that's not going to change. I know that's annoying, but that's how it is. If you want to go back to the default theme, you can use schemer import default.prf, and there you go. Now you're back. One more thing I want to mention. If we're in a script, which we're going to be doing as a class, for every lab, we're going to be using scripts. If you have a section, so you see by default it's yellow. Let's say that we change our theme here to schemer import. Let's do solarized dark. I know a lot of people like this theme. I don't love it personally, but you see that this section color, you can hardly even tell. It's there, really faint, but the section color, that's going to change as well. And let's say you want to go back to the default settings. So you can use that command that I showed you earlier, schemer import default.prf, or you can click on preferences, and then go to colors, and you can click on restore default colors, and click apply. But you see, once we did that, this section color, it's still, that's not changed. So to change that, you go to Programming Tools, Restore Defaults, and then Apply. Or again, you can just type in this command, and it'll make both of those changes automatically. Alright, so anyways, that's how you do dark mode in MATLAB. Again, like especially if you're working at night, the default setting is just terrible. It's gonna blind you. Alright, so I think that's gonna be it for today. Let's double check though. Let's go back here. Yep. Okay, so next week we're gonna be doing our first lecture. Remember, that's going to be on Zoom. So don't go to school if you don't need to go to school. It'll be on Zoom. I'll be using my iPad, sharing my screen that way, and we'll take notes. And then in week 3, we're going to have our first lab. That's going to be in person. We're going to meet at E22. That's week 3. Okay, next week is virtual. I want to restate that. And again, I'll post this to Canvas as well to make that clear. I'll post that right here. Oh, yeah, sorry, I missed your question, Samson. So, yeah, let's see. How did you get the scheme folders to show on the left side? Yeah, so yeah, you need to click on add-ons up top, and then you can click on, let's say you already installed it, right? Let me go back here. I always forget to move that over. So let's say that you already installed MATLAB Schemer. Gotta click on add-ons. Okay, and this window will pop up. And then we can click on Manage Add-ons. And then you see we have MATLAB Schemer here. We can click on these 3 dots and click on Open Folder. And then now, on the left here, we're in that folder. Again, you don't need to be in the folder to actually run that code. But this is just so we can look at all of the schemes that we have. But yeah, if you're not in that folder, it doesn't matter. You can still type it in, so monokai.prf. and it still works. Okay, so let's see. Okay. All right, so yeah, that's it for today, guys. So thanks for tuning in. If you have any questions, you can stick around and ask. But if you don't, then that's it, and I'll see you guys next week again on Zoom. All right, so have a good weekend, and I'll see you guys then.
All right, thank you, Professor.
Thank you, Professor.
Yep, see you guys.
Thank you.